Hi, I'm Jesse Luke, and this is Funky Pharmacology. Today's lecture is going to be very simple. What is pharmacology? It's the scientific study of drugs. That much is obvious. But what does that entail? What's the purpose of it? What's some history behind it? What other fields are essential to making this a worthwhile academic endeavor? So let's start with what a drug is. A drug is a chemical substance that induces a biological effect in a living organism. This definition leaves a little bit to be desired for it, but in its simplest terms, it's accurate. We exclude vitamins and nutritional requirements. But once again, this is a chemical substance that induces a biological effect in living organisms. That's all a drug is. Caffeine is a drug. Nicotine is a drug. Ethanol, commonly known as alcohol, is a drug. So most of us are on drugs, whether it be that cup of coffee in the morning, or it's a beta blocker for your blood pressure, or it's methamphetamine for recreational purposes. Pharmacology is a recent area of science. Say only about 100 years old. Now, long before that, there was plenty of herbalism around, magical potions, cures, but none of it was done with the scientific method. They weren't tested rigorously. The rules of chemistry were not even really developed at some points in time. Real breakthroughs came in the late 1800s when synthetic chemistry was developed. That allowed us to be able to create drugs, to be able to use science, understanding the chemical structure of these different chemicals and what they did to the body. Some worked, some didn't, and now it comes down to finding drugs that are both safe and effective. So back to the history. Big point in pharmacology, historic point, was Paul Ehrlich. Paul Ehrlich studied immunology, studied pathology, and most importantly, he was responsible, in 1909, he discovered the salvarsan. This is an arsenical-based chemotherapy. Now, I want to point out the word chemotherapy, often associated with anti-neoplastic treatment for cancer, did not originate that way. Chemotherapy, you break the word in half, chemotherapy, that just stands for chemical therapy. It's still used to refer to antimicrobials at times in journals, but it is the origin of the word. Now, salvarsan, and then later on to neosalvarsan, which was a modification to help with the many adverse effects caused by salvarsan, was the first effective treatment, first drug to successfully treat syphilis and also human African trypanosomiasis, better known as African sleeping sickness. It remains the only drug that could help cure syphilis until another 20 years later, 25 years later, with the advent of antibiotics, namely penicillin. Now, it's important to note that pharmacology does not stand alone like most sciences do. It is an extremely interdisciplinary field. Pharmacology is an extremely interdisciplinary field. It's many sciences. To get to pharmacology, we need all of this. Depending on what drug you're researching, you'll use more, some than others. Chemistry. This is probably your biggest one here that you're going to need the most. Both biochemistry and organic chemistry. Without that, you can't do pharmacology. Genetics is important today more than ever, especially with upcoming anti-neoplastic treatments that focus on certain mutations. And by targeting that mutation, we can actually, in some instances, cure cancers or keep them at bay for so long that you can have a normal lifespan, turning deadly diseases into manageable long-term conditions with drugs that don't even have that many side effects. A good example is chronic myeloid leukemia. The first drug that came out was called imatinib, tyrosine kinase inhibitor that targeted the BCR-ABL translocation. Before that, CML was practically a death sentence. Now, there's even cases where people that have taken it for years are even able to come off the drug and be okay. So we can cure some cancers using pharmacology. I think that's amazing. Immunology, just as important, especially when we're talking about antimicrobials, anything like that. Neuroscience, this is going to play a big part in neuropsychopharmacology, which is the focus of this show. Neuropsychopharmacology, everything I said about pharmacology applies to neuropsychopharmacology. The difference is neuropsychopharmacology is very focused. It's a combination of two separate types, subdisciplines of pharmacology, psychopharmacology and neuropharmacology. Neuropharmacology focuses on the synapses, the nerves, any central nervous system tissues, basically. Psychopharmacology is anything that can affect behavior, which can include cognitive symptoms, mood. Obviously, there's a lot of crossover there. Neuropsychopharmacology is the umbrella term. You'll end up working, crisscrossing a lot when you go into that research. Statistics. Statistics are important for trials. It allows us to get a better picture of how effective a drug is, how safe a drug is. Because we have to do trials. Because we obviously can't try a drug on every person that's sick. So we use statistics to try to extrapolate to see how many people will benefit from this. What's the number needed to treat? Pathology. We're using drugs to treat something that's wrong. So pathology in its many, many variations is important, because what are we creating a drug for if there's nothing wrong? And understanding what the underlying pathology is can be just as important for drug development, target focusing. Even though we can make a drug that works, even though we don't fully understand the pathology of something, I feel relatively confident in saying that there's pretty much nothing in medicine that we fully understand. There's always more questions. That's science. That's the way it works. A good question will lead to more questions. It's slow and incremental, but we learn more and more and more. A&P, anatomy and physiology. Reasoning behind this requirements should be self-evident. You need to know the different parts of the human body and what they do. Molecular biology. This is extremely important, especially now, especially when we're studying small molecule pharmacology. Molecular biology allows us to go all the way down to a small level and look at a receptor directly and understand and study that receptor, the different forms it can take, and how best to target those receptors, how it reacts to research chemicals, how it reacts to drugs, can lead us forward in understanding pathology of these disorders and also how to better treat these disorders. And with that, I'm going to close out this lecture, and we're going to talk about the two main branches of study in pharmacology: pharmacodynamics, how a drug affects the body, and pharmacokinetics, how the body metabolizes and affects the drug and substance. Thank you for watching.